All right, so we just finished up a test on solving quadratics. What 3 ways did you learn how to solve a quadratic equation? Quadratic formula is 1. Factoring is 2. Completing the square is the 3rd one. And again, completing the square was just a way that we could end up factoring. Okay? So that's 3 ways to solve. We're going to continue talking about that even as we move into a new unit. But you'll notice we're still going to be working with quadratics. All right, so this unit is all about graphing them and figuring out the characteristics of these functions that helps us graph them. So we're going to do some work around on the whiteboards today to practice, but ultimately we're going to end up looking at the graphs of these. Okay? So the first way we're going to do this is by looking at something called vertex form. All right, so this is vertex form right here. All right, I'll go through those letters. The A, all right, indicates whether it's going to be opening up or opening down. So if you see a positive for A, if you don't see anything, so it's positive, it's going to open up. If you see a negative at the very beginning of these functions, the parabola is going to open down. Now the H and the K is the vertex, all right? So the vertex will always be letter H and letter K. And what always confuses students every year is, what do you notice about in the parentheses? It says X minus H. So when you try to write letter H, you always have to think what? Think opposite, okay? But what about for K? See, it says plus K? That whatever the sign is in front of K will be the number. All right? So remember, think opposite inside the parentheses. And we'll practice, obviously. All right? So let's do one together. All right. So the first thing that I do when I do these problems is I always write down A, H, and K. All right? Now, A is always at the very beginning of the function. What is at the very beginning of the function? Nothing. So what is A? A positive 1. Now, be careful here. It's where it gets tricky. What is H? Very good. It's negative 3. You have to think opposite. All right? You got it. Always think opposite. But be careful, Lissandro. That rule does not apply to the K. So what is K going to be? Positive 1. Okay? Now, the first part. Determine whether the function opens up or down. What is letter A? A positive 1. The fact that it's 1 doesn't matter for up or down, but the fact that it's positive means it's going to open up. Now, part B, for the axis of symmetry, is always going to be X equals H. Always X equal to H. So what is it going to be for this problem? X equals negative 3. Now, we'll get into more why we want the axis of symmetry. The interesting thing about the axis of symmetry is that it's not a part of the parabola. All right, I'm going to repeat that. When you graph these, the axis of symmetry is not a part of the curve, the parabola. All right, we use it to help us get more of the curve. All right, so you're going to see how it comes into place here. Now, the vertex is always H, K, the ordered pair H, K. So what is it for this problem? You got it. Negative 3, comma 1. Now, for the Y-intercept. Yes? Sure. For the Y-intercept, there's no easy way to get the Y-intercept, but think back to when you were in middle school or maybe early high school. How can you find the Y-intercept? It's a small one. How can you find the Y-intercept? Does anybody remember how to find the Y-intercept of anything? No, it's not. We're talking about vert. It doesn't matter what form, actually. Well, let's ask this. Do you know what the ordered pair for a Y-intercept is always starts with? No, it's an ordered pair. 0. 0, because for a Y-intercept, it's always going to be 0 and some number. All right. Remember, the Y-intercept is on the Y-axis. So you're not moving to the left or to the right, so your X value is 0. So the way you're going to find the Y-intercept today is you're going to take this 0 for X and plug it in for X. So we're going to do F of 0. All right? So if you plug in 0, you get 0 plus 3 squared plus 1. Okay, what is 0 plus 3? 3. What is 3 squared? And what's 9 plus 1? 10. So our y-intercept is 0, 10. And I'll accept it if you write 10 or y equals 10, but you know my preference. What's my preference? The ordered pair. I would prefer you to write 0, comma, and then the number. No, it's 0, 10. It's hard to see. That's a 10 there. It's a 1. 0, 10. Okay? Now, part E says to graph it. All right, so here we go. Let's graph it. You should have a slide right next to it that's ready to be graphed on. Okay? What was the vertex? -3, comma 1. So plot that first. Go to -3, comma 1. That's the vertex. Now, your brain should already be able to visualize what this is going to look like. We said it's going to open which direction? Up. So you can imagine right now, you're going to have a parabola that's opening from that. Okay, so if it was just a sketch, you could just make the curve and be done. But this is asking for the actual graph of it, so it is important to get the correct ordered pairs that are on this curve. All right? The next thing I do is I plot the axis of symmetry. Now, what was the axis of symmetry? X equals -3. Does anybody remember anything about x equals a number when you graph? Why is that a special case? Zach, you have something? It's not it ends up being where it crosses the x-axis, all right? So, but it's not what I'm looking for, Zach. It's something about what it looks like when you graph it. It's actually vertical, all right? So whenever it's x equals some number, it's always going to be a vertical line. What's really nice for us is that that vertical line always goes through the vertex, okay? So take your pen or pencil and do a vertical, do a dotted or dashed line that goes through that vertex. Why am I doing dotted or dashed? It's not a part of the parabola. That's exactly right. It's not a part of the parabola. And if it's not a part of the parabola, I don't want it to be solid. All right? So in this case, I want it to be dotted. All right? Now, at this point, we only have one more point that we can plot. What's the other point that we found? The y-intercept, which was 0, 10, 2, 4, 6, 8. It's all the way up at the top. Now, here's the cool thing about the axis of symmetry. Does everyone see that y-intercept of 0, 10? Everyone see that? How far away is 0, 10 from the axis of symmetry? How many units? 1, 2, 3. Now watch this. Remember, it's called the axis of symmetry. So 1, 2, 3, you get a point over there as well. Because this parabola is going to be symmetrical about that axis of symmetry. Okay, how are we doing so far? Yes. Okay, remember we plotted the y-intercept. This parabola is going to be symmetrical about this dotted line, which means it has the same points on either side, the same distance from that axis of symmetry. So because this y-intercept, Jennifer, is 3 units from the axis of symmetry, it gets another point on the parabola that's 3 units on the other side. Yes, Joseph? So it's always going to be dotted? The axis of symmetry will always be dotted because it's not a part of the parabola. I'm going to draw the parabola soon, and that's what's going to be solid. Now, if you have a calculator, I'm going to show you a way that you can get more points. So if you have your calculator, go and take it out right now. If you would like a calculator, go grab one real quick. All right. So if you have your calculator ready, turn it on, and I want you to click Table. Click the button that says Table. Everyone see when you click Table, it asks you to enter a function? Remember what I told Daniel? The button table, right? It starts with the letter T. Cool. So when you click Table, you're going to type in after the equal sign. So use parentheses and type in x plus 3, close the parentheses, raise your 2, and then plus 1. It should be the letter X is on the left-hand side, where it says the letter X. Now wait till you get there, Melanie. You should square it. It's okay if you hit enter once you type it in. It looks good. You can hit enter, but then don't keep going after that. Excellent. Good job. Zach, you type that in. That's right. Plus 1, yes. Make sure you type the whole thing in. Daniel, what's up? You can get it? Looks good. She just hit enter. X plus 3, right? You're typing in the function. Okay, so once you type it in, if you hit enter, you see it says something about starting point. All right, many of you have 0 in there. It's up to you. You can start at 0, 1, -1. It doesn't matter. It's going to go to a table. The key thing is that, do you see where it says step? Step should be 1. You want step to equal 1. If it doesn't, it should. Then just hit a bunch of enters until you get to OK, until you get a table. Now, when you get to that table, you should see it says 0, 10. Does everyone see how it says 0, 10? Go ahead and find your vertex. Scroll up or down to get to -3, 1. Does everyone see that? Does everyone see that one? No, you haven't found -3, 1. You got to scroll to the negatives. Scroll to the negatives. Right? Isn't our vertex -3, 1? You got to go up to the negatives. Got it? Now, the reason I sent you here is because if you want to find more points to plot, here's the table of values. All right? When people started graphing, they needed a table of X and Y values. So I would prefer that you only do integers. I don't expect you to graph any fractions or decimals. All right? So what is another integer point that's in your table? Say it again. -2, +2. All right, so I'm going to plot -2, +2 right here. Now, Josie told me that point, -2, +2, and what do I immediately notice about that point? It's 1 unit away from the axis of symmetry. So that means I don't even need to ask you for another point because I know on the other side, 1 unit away is another point. I'm not lying, actually, it's how it works, right? Axis of symmetry. Now, once you finish doing this, you should see that there are not any gaps in your parabola. All right? This is how you do that. Start at your vertex. All right? When I move 1 unit to the right of my vertex, we have a point, correct? What happens when I move 2 units to the right? Do you see a point there? So we need to find that. So go into your table. What is the y value for -1? -1.5. Thank you, Daniel.
How do you find that?
In your table. It might be going up, though, depending on where he is.
How do you know it's that way, not like negative?
Well, I did it. Remember, I'm looking for the gaps. The gap was at x equals -1. I didn't know where this point was. It's right there. You could have done the other side. Look, right? I don't have a point at this x value of -5, which is also going to be +5. Yes, Amy? Correct. You're graphing it. All right?
They already have a point. Like there'll never be more than this.
There'll never be more than 1 point because then it's not a function, right? If you have more than 1 point on an x equals a number, then it's not a function. It fails the vertical line test. So there'll always be 1, and then check. If I move to this one, +1, if you went to +1, somebody go to +1 in their table, you're going to see it's off of the grid. What's the y value for +1? 17, right? And 17's off the grid. All right, same thing with -6. That'll also be over here. 17 off the grid. Okay, so I'm not expecting you to graph off of the grid. But this is a complete picture of what the parabola looks like. So now I'm going to make that curve. And this should be solid. No, it needs to be solid. I will take off points if it's not. No, well, it is possible if I was graphing inequality, like if it had said less than or greater than. But for our purposes today, Lysandra, it will always be solid. Now, once you finish this, I want you to put your pen or pencils down. Because you are done. You've finished the problem. That's how it looks to find all the stuff and then graph it. But I want to show you a cool way that you can find the points without using the calculator. So once you're done, put your pen or pencil down. Now again, you're going to have calculators, so you don't need to do it this way, but I do it this way and it's much faster. Got it? Excellent. Okay. Now, remember the vertex. Do you guys remember the vertex? All right. It was at -3, 1. When I move 1 unit to the right, that's 1. What is 1 squared? It's a quadratic function. What's 1 squared? So if you go up 1, you get a point. Now watch this. Go back to the vertex. Go 2 to the right. 1, 2. What's 2 squared? 4. Go back. Sir, thank you. Let's go 3 to the right. 1, 2, 3. What's 3 squared? What's 3 squared? 9. Now, that only works if your A is 1. Remember how at the very beginning our A was equal to 1? It works if A is 2 or something different, but it's more challenging to do it that way. So if we get to a point where we have a problem, Lysandra, that A is not 1, like a half or 2 or something, I'll show you how to do it that way as well. All right? So if you want to start trying it that way, you can. Otherwise, you can use your table function in the calculator. Yes, Lysandra?
I was going to say it was 1, but I still think I'm down.
It still would be fine. You would just go 1 to the right and then 1 down. All right, it's the same way, just going in the right direction. Let's do another one. Let's do another one. All right, we'll try it this way without the calculator first to see if you guys like it. If not, you can always use the table function. All right, so what is A in example 2? It is 1. What is H? Be careful. Very good. +2. And what is K? -1. All right? Now, is this going to open up or down? Up. A is a +1, so it's going to open up. What is the axis of symmetry? Remember, it's x equals h. X equals +2. So we're going to have a vertical dotted line at x equals 2. What's the vertex if it's hk? 2, -1. Very good. Now, the y-intercept is 0 and some number. So we have to plug in 0 to this function. Now, every year I do this, I get students that wait to find the y-intercept until they use their table function in the calculator. All right, so if you want to type in this function into the function table, then you can get the 0, your number, if you don't want to do the algebra. All right? Yeah, just clear it out. You probably didn't. If you ever worried that you broke it, hit second reset, and then you can reset it. Second, and somewhere near the bottom, second, then like
0.
second 0, and then hit yes, and then you'll be fine. You can always do that. When in doubt, turn it on and off, right? You guys all have electronics? No, that's not what you do? Man, it's not working. Just turn it off. Wait 10 seconds, turn it back on. And then call Comcast. All right, so what's 0 minus 2? What's 0 minus 2? -2. -2 squared is 4. 4 minus 1 is 3. So the y-intercept is 0, 3. And if you're using the table, you should have typed it in and found it was 0, 3.
-2 times 2?
No, I did 0 minus 2, which is -2. -2 squared would be -2 times -2, which is +4. And then 4 minus 1 is 3. All right, now let's graph it. Okay, what's the vertex? Very good. So 2, -1 is right here. 0, 3. So 2, -1 is the vertex. Always put your axis of symmetry through that. I'm mixing it up, man. That way you can choose what you want to do. A dotted line through there. What's the y-intercept? 0, 3. And the moment I plot the y-intercept, I notice how many units away is the y-intercept from the axis of symmetry. It's 2 units, right? It's 2 units from the axis of symmetry. So go 2 units to the other side. and you get a free point. Now, you could use your calculator to find the gaps, right? Ultimately, as Amy was asking about, you're trying to fill in the gaps. But you know I like to do this quicker. So I go to the vertex. If I go 1 to the right from the vertex, what's 1 squared? 1. So I'm going to go up 1 and put a point. And those of you that are using the table should see that 3, 0 is a point. All right, and because of the axis of symmetry, positive 1, 0 is also a point. Now let's see if we can get one more. If I move 2 to the right, you'll notice we already have that one. Remember, we already have that from the Y-intercept? So if I move 3 units to the right of the vertex, 1, 2, 3, what's 3 squared? So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So that y value of 8. And then go 3 units to the other side. And you can make your curve. All right, so once you finish drawing this, you are done, but I just want to ask you one more question, and I'm going to rewrite the function here. It was x, what was it, minus 2 squared minus 1. Again, you don't have to write the function again. I just want to ask a question about this function based on your graph. Great, you don't have to. I just wanted you to graph it. So my question is going to try to tie in what we did last unit. So here's my question. Here's your graph of this function in vertex form. Okay? I didn't ask for this, but now I am. What are the zeros for this function? What are the zeros? So what makes this 0? What are the zeros for that function? And you should be able to see it on the graph.
-1, negative.
Close. When I'm asking for the zeros, and you have the graph, you should be looking for a certain point or points. You should be looking for the X-intercepts. What are the X-intercepts of this graph? 3.
Guess what? I said 3.
You said -3.
No, I said 3.
No, you didn't.
I said negative.
Then you said 3 and -1, which is not it. And 1. So your zeros are 3, 0, and 1, 0. Those are the zeros for this function. And did we have to factor? Did we have to factor?
No.
Did we have to complete the square? Did we use the quadratic formula? We didn't use any of that. When you get the graph, when you're given the graph on the SAT, and it's asking you about zeros or x-intercepts, just find them on the graph. All right? So these would be the solutions for this function. It makes it 0. That's not what I'm asking you to do today, but I'm trying to tie it all in today to begin that conversation, because the SAT doesn't view these as separate units. They view all quadratics as one thing. So I split it up because it's a lot, but I want to make sure your brain starts to look at it all together. All right? Any questions?